Hello, my name is Pauline Bimberg and I would like to welcome you to my presentation of our paper on anchored jumping for maneuvering in immersive virtual environments. According to Bowman and Kulik's, navigation in virtual reality can serve one of three main tasks: exploration, search, and maneuvering. When our user here enters this virtual room, they might want to explore it, looking at different aspects of the space that might catch their interest, search the room for an object that they know is there somewhere, or search a path through the room to the known location of an object. Or they might want to maneuver around a certain object in the room to view it from different perspectives. Compared to the other two tasks, which often require the user to cover a larger distance, maneuvering often relies on smaller translations paired with rotations to keep the object of interest within the user's field of view. For users who are not able to do this by walking in their tracking space, this can become quite bothersome if they are using a navigation technique without integrated rotations, like, for example, virtual jumps or teleportation in vista space. As you can see in this video, the user has to constantly alternate between jumping to a new vantage point and physically turning back toward this object of interest. Doing this for several objects can become tedious or even impossible if the user is entering VR using a setup that does not allow full turns. Since teleportation is a very common navigation technique that is especially appreciated for its provided user comfort, we decided to look into solving this problem, starting with looking into existing integrations of virtual rotations into the jumping process. One common approach to virtual rotations is giving our user the ability to turn on the spot on the press of a button using so-called snap turns, as seen in this video taken in SteamVR Home. This does not, however, fix the problem of the repetitive motion sequence for maneuvering. Here, navigation techniques that connect virtual rotations and translations become relevant. One of the first approaches to integrate virtual rotations into the target planning process of a virtual jump was introduced in connection to the point and teleport technique. Here, users could turn their wrist while selecting their target point to simultaneously select a new viewing direction after the jump. Unfortunately, users testing this addition to the teleport technique complained about dizziness and disorientation when using the feature during navigation. Looking at techniques built specifically for virtual maneuvering, most published approaches were built for the use with a large stereoscopic display wall. These techniques often give the user the opportunity to select a center of rotation in the virtual environment and then select a position from which they want to view the set point of interest. Inspired by these approaches, we decided to develop a maneuvering technique specifically built with HMD users in mind. Based on the information we gathered from related work, we developed anchored jumping, an extension of the jumping technique built specifically for maneuvering tasks. Similar to known virtual maneuvering techniques, anchored jumping starts out by letting the user choose their center of rotation. We do this by choosing a point on the floor with our jumping ray. To keep the technique easily integratable with other techniques, the user could now trigger a virtual jump to the chosen destination. If the user decides to plan an anchored jump, they can simply move their controller away from the set point of interest to choose a new position from which they will automatically look onto the now specified rotation axis. To ensure our user's continued well-being, we only allow the specification of rotations around the upright axis. When the user is content with their selection, they can confirm their choice and will be teleported directly to the target. Here, we have decided for an instantaneous transition to avoid our users getting sick by being driven around a curved trajectory. As you can see, the rotation axis is still visible after the virtual jump to give our users some visual continuity between their old and new perspective, but fades shortly after to give the user an unobstructed view onto the point of interest. Although our technique already worked well in general, we noticed one particular problem with our new approach. As you can see here, our user first selects their point of interest and then turns away from it to select a new target destination. Since the jump is applied to the camera position, the user will land directly facing their point of interest, but still turning their head away from their previous forward position. This results in them having to turn their chair to get more comfortable. As you can see in this example video, Maneuvering around a set object of interest resulted in our user still performing a large range of physical rotations, which is something that we meant to avoid by using virtual rotations. To deal with this problem, we suggest the addition of counter turns to our anchored jumps. For this, we simply assume that the user selects a target that will be comfortable in front of their body when they start the selection process. When a jump to the target position is triggered, we can simply take the angle between the user's previous forward direction and their selected target, and add this onto our target rotation. This way, the user does not directly look at the rotation axis after the jump, but instead has to turn their head back towards their goal, remaining in a comfortable interaction space the whole time. In this video snippet, you can see how the application of counter turns centers the user's movement around their initial forward direction. In a pilot study with 9 users, counter turns were generally well received and were shown to reduce the movement radius of all of our users. Since most applications do confront the user with a number of different navigation problems and are not just built around maneuvering, our next goal was the integration of our technique with other rotation methods. First of all, our implementation lets users trigger a normal jump by selecting a goal on the floor, confirming it by pushing the trigger button all the way through, and then letting go of the button to directly trigger a jump to the target. If users turned their controller around the roll axis during target selection, they were able to change their future viewing direction at the target point. If users first selected a target and then moved their controller to the side instead of triggering a jump, they were able to plan an anchored jump. Finally, we allowed our users to trigger small rotational jumps on the spot by pressing on the touchpad of their controller. The first phase of a user study compared all 3 of these presented virtual rotation methods in a maneuvering task, similar to that of our pilot study. To make sure that our users needed to land in a position where they could both view the target and comfortably interact with it, we added the task of touching a target sphere turned towards the given object of interest and then reading a word that was previously hidden inside of it. This process was repeated several times for each technique using target objects of 2 different sizes. In addition to our controlled comparative study, we invited our participants to try out the presented combination of all rotation techniques in a free study scenario, using an indoor environment with several rooms. Users were asked to explore the different rooms and then maneuver around the marked target areas to take a closer look at them. As you can see in this graph, our qualitative task showed that our users took longer to plan anchored jumps, but took the lowest time to reach the target sphere after the jump, which could point to a higher precision in the planning process with this technique. Furthermore, users reported the lowest amount of confusion when using anchored jumping. In our qualitative interview, most users indicated that they would prefer anchored jumping over the other 2 techniques for maneuvering tasks. The other 2 techniques were employed for general exploration of the virtual space and to get out of tight spots in our free usage scenario. Interestingly, none of our users relied on physical rotations during the task phase, although they were seated on a swivel chair and had the opportunity to fully turn around within the tracking space. Although the pandemic situation led to us performing our study with a smaller sample than we would have wished for, we can draw some initial conclusions from our work. First of all, our anchored jumping technique with added counter turns seems to work well for maneuvering tasks in VR. Furthermore, different navigation tasks require different rotation methods, which should be taken into account when developing complex applications. And finally, all presented forms of virtual rotations did not create confusion for our users, which could be partly due to the rich spatial cues that were available in our indoor environment. For future work on maneuvering in virtual environments, we would be interested to find out how preset rotation anchors could be offered in maneuvering-heavy scenarios, like exploring different exhibits in a virtual museum space, and how anchor jumping can be expanded for multi-user navigation. For now, however, I would like to thank you all for your attention. I am looking forward to answering your questions.